Let's talk about lookup functions. This is where you're going to be looking into some sort of data table to find a second value off an index value. And we're going to be looking at how you do that using first the match function, the index function. Index and match working together is a construction, which is the best way to do lookups. The more popular but less effective VLOOKUP function, and then the HLOOKUP function, which is a transposition of VLOOKUP across the other direction. Then we'll talk about other row positions and some extra kind of subtleties or differences or different ways you can do lookups. And then we'll finish with a little exploration of what exact versus approximate lookups are and what kind of data you need and what the impact is on your lookup. So first, you'll need some sort of table of data. And what we'll do is we'll grab the saturated steam table off of the engineering toolbox. So this is a table of the properties of steam as a function of pressure and temperature. So we'll grab that, copy it onto the clipboard, and paste it into Excel. Right, so we got the pressure, the temperature, and then some dependent properties, specific volume, density, and then the enthalpies at different states, and then of course specific entropy. So the way this works is we'll have some values that are going to be independent variables, and then values that are dependent variables that we're going to look up on. The data looks pretty good, but if you notice here, there's a data point that had a footnote that is being imported, so we're just going to trim that to make that fixed. Alright, so the match function. The match function takes some input value, and from that input it will give you what the position in a row is. So for example, let's say we want to find what 100 degrees Celsius would be in the position. So what we do is we take match, and then it has three arguments that it accepts: the input, the array that it's looking up in, and then what kind of match you want to do. So our input is this 100 value, and then the array that we're going to be looking in is this temperature array here. So we'll drag this all the way down. Alright. Now, there are three kinds of arguments it accepts: 1, 0, and -1, where 1 will find the largest value less than or equal to lookup value in ascending data. 0 is just going to be an exact match that finds exactly that position, and -1 is the greatest value less than or equal to in a descending data array. And we'll talk a little bit more about the distinction of these when we get to exact versus approximate. For now, let's just do an exact match. So give that the 0. Alright, 15. So what this is telling us is that our input, 100 degrees Celsius, is the 15th position down. So let's create a new column here, and this will be the row index. 1, 2, 3, 4, and then just drop fill. So input match. So temperature 100 degrees, match row index 15. There we go, 100 degrees Celsius. Now, what index does, index here takes as many as 4 arguments, but we're only worried about the simplest formation, which takes 2. So we'll talk about having an array as the output range and then some input row number. Column number here is needed for when you do a two-dimensional table lookup, which we'll look at in a different video, and then the reference row, column, and area number is for a three-dimensional lookup, which we'll talk about in another video on top of that later. But for now, we're only worried about feeding it 2 arguments. One is the output array. So let's take density. So we have the density of steam, and then we feed that some row position number. So we'll say right there, take that row 15. So this is saying the density is going to be 0.598 kilograms per cubic meter. And what this is doing is we're looking in this density row at the 15th position across. So when you do a lookup, what that is talking about doing then is taking those two functions together. The index fed the match, and what this is going to do is we'll look in, we'll have an output range that we'll be looking in, and then we feed it the position of where we're going to look using match, which takes the input range we're looking in, and then the type of match. So there we go. So this is going to be, this is how you do a lookup with index match. You feed it an input into match, which gives how many rows down in an index it is, and then the index function takes how many rows down in your output range you're going to feed it. Pretty simple, right? Well, let's see how that compares to VLOOKUP, which you're going to see referenced quite a bit. It has a very similar sort of structure. Takes 4 arguments, but they're going to stick that L in there, but they're a little different. The first argument is the lookup value, so that's the input you're feeding it. And then some table array, and this is going to be a table of all the data, and the first column of your data has to be the input value. So I've grabbed specific volume, it needs to be temperature on that same input row there, right? Then this third argument is the column index number. This is how many rows over you want to feed it to get the right output. So if we're looking for density, which is the 1 to 3rd column over, we give that a 3. And then just like match, it can take an approximate match or an exact match, but it can only take one kind of approximate match, only in ascending data, not in descending data. We'll get into that a little bit later when we talk about exact versus approximate. So again, we'll feed it that false, Boolean 0, and there we go. We get the same thing. So index and match in VLOOKUP are going to be performing exactly the same function, but a lot of people that are involved in Excel and are Excel developers are going to push you towards the index match construction because it's more clear. You have an input range, an input number, and an output range, and it's pretty easy to keep track of what's going on. Let's talk about HLOOKUP. HLOOKUP is pretty straightforward, actually. All we're doing is taking this data, and then rather having it in a typical vertical structure, all that happens is we're looking at it in a horizontal structure. So if we transpose it like that, so we have temperature across the top here, and then density across row-wise. So then, once you understand that it's the same function as VLOOKUP with the lookup rotated 90 degrees, HLOOKUP is pretty easy to use by comparison. If you understand VLOOKUP, you understand HLOOKUP. You feed it that input, you feed it the table array, and it's the top row that's the input number there. And then you say how many columns down you want your output to be. So for example, if we're still looking at density, 1 to 3rd column down, we feed that the 3, and we'll still stick with an exact match. There we go. Same thing with an HLOOKUP. Now, even then, index match can do exactly the same thing, because you can feed index match with with a horizontal rows just as easily as vertical rows. So we have this output range in index in the first row, and then we feed it match to get our position using that input. The input row. Oh, I'm grabbing pressure. I need to grab temperature. And then we'll tell it to do that exact match again, right? Close both functions, and there we go. Assuming I can ever spell density correctly. So that's how index match, VLOOKUP, and HLOOKUP work. Now, there are some second order or more complex things you can do. For example, with index match here, if you want to take this function, then you can even change the output to look for something that is in a different order. So let's say that rather than density, we wanted to get specific entropy, right? So this is how much entropy you're going to be seeing in a pound of steam or in a kilogram of steam at a particular temperature. And what we do there is we just take our output range in index and we move it over to that correct value there. If you wanted to, see 7.335, there we go. Oh, row 15, 100 degrees Celsius, like that. For VLOOKUP, all you would have to do is change that number there to the correct row number. 1, 2, 3, 4, 5, 6, 7, row position 7. 7.335, yep, right value. And we'll undo that. Now, the reason why index match is better than this is because let's say you want to get a value that's to the left of your input data. You want to get over here and get the pressure rather than the specific entropy, even though pressure is this independent variable that's also controlling it here, right? 101.33 kilopascals. Well, you can't do that with VLOOKUP because you're trying to look to the left of the first column, and the leftmost column is always where VLOOKUP automatically assumes your index value is feeding to. So that's one reason why index match is easier to use than VLOOKUP, right? And that's this other row positions kind of argument here that we're talking about. Now, let's get into what exact versus approximate row lookups is going to mean. So, let's say that we have this data here, right? Temperature going up, but more importantly, our output is also going up. So, let's say that we can delete those. All right, so we're looking at this index match, right? And we want to consider what it means to have an exact versus specific or exact versus approximate, right? Let's say we want to get somewhere it's not quite in there, 99 degrees. Well, with an approximate match, you can do it, but with this exact match, it's going to look for exactly that value down the row, right? Temperature, there's no value for exactly 99, only 99.6 and 98.2. So it's going to throw an error. Now we know it's ascending data, so what if we give it this number one argument, less than or equal to? Well, now it's going to deliver a value all of a sudden, right? 563. 563. See, row 13, 98.2. It's the It's the smallest value that is less than or equal to our input, right? Or the greatest value less than or equal to our input. 99, 98.2, less than, equal to, 99.6, greater than. So it doesn't take this row position 14, it takes row position 13, right? Now, if you're really going to do this for steam lookup, then you could interpolate your data very easily by just taking in here and then saying, all right, let's get the next position by giving +1 on your match. So what this is going to do is take the match and then increment it down another row, 0.59. And we'll look at density. There we go. Row position 14, 99.6. So you can take those two and do your linear interpolation on them to get the data there. So it's very easy to set that up with index match. You just do +1 on your formula. You can't really do that with VLOOKUP very easily. Now, let's say we want to look in a value that is descending data. So for example, let's look at specific entropy here, right? We've got it starting at 9.058 kilojoules per kilogram Kelvin, and then it drops down to 6.069 at 250 degrees Celsius, right? So let's say we want to take that instead. So what we're going to be doing is moving our index range from feeding on temperature to feeding on specific entropy there, right? See there? All right, looking up in there. Didn't change the number. Still doing this number 1. So what it's going to do is look for the number 99. Well, what's the largest value for density that's going to be that's going to be less than or equal to 99? It's going all the way to the bottom of the table, even though this is the smallest value. So we're feeding it this argument that's asking for less than or equal to this greatest possible value. You'd expect that since this value right at the top is the largest value, we'd be feeding the input from there. But that's not what's happening when you have your data in descending order and you're trying to feed it into a search algorithm, that binary search that's expecting ascending data. So if we go to an exact match, it's going to throw our error again. So let's just grab some value at random, 6.73. So, oh, don't have numlock. There. So 6.73. Density 3.425. There we go. Now, let's say you wanted to do a specific match here. Well, let's feed it -1, right? Find the smallest value that is greater than or equal to lookup. So it'll approach it from the top going down rather than going right for an exact match. There we go. 3.425, right? 6.73. 3.425, right? Because it's finding that greatest value, that this best value is greater than or equal to. So let's just feed it some proper integer. All right, there we go. Input is 7. We're looking for 1.55, right? There we go. So we're feeding it 7. And then it's going down. And it's going to find that we're looking for 1.55. Density 1.55. There we go. 7.014, right? So that's the smallest value that is equal to or greater than 7. The next row down, less than 7. So that's how your exact versus approximate matches work. Realistically, you're probably going to be looking for exact matches in any kind of data you're doing a lookup for if you're doing database work, because you're looking for exact matches only, right? So it delivers this NA error that can still be valuable information to you if that's what you're looking for. Now, if you're doing some sort of property lookup, then you're probably going to be wanting to do some kind of approximate match, and you might want to be interpolating between the data there, which can be another video. Alright, so that's an introduction to lookups. It's a lot to take in and kind of a lot to chew on, but it's a really critical thing to understand if you want to get better at Excel.